Hello, college algebra, and welcome to another educational video. I hope this one will be fun. I tried to put some personal details in it to keep you awake. For a lot of you who are really have done a lot of algebra recently, this might be too much review for you. So if this video is putting you to sleep, I would recommend turning it off and trying the homework and seeing if you need anything there. But if it's been a long time since you took algebra, or if you're not that comfortable with algebra, or if you're busy doing some dishes and you need some company, then yes, I would say watch this video, okay? So I'm going to give you some examples. We're going to review points and lines in the plane, and I'm going to do a lot of linear function review in here because that's one of the first things we're going to do. So I'm going to give you an example of a linear equation in two variables, which is at my first ever job that I ever had in the whole world, right? I worked, like many of you and many of your family members, I worked detasseling corn. I worked in agriculture, and I made $2.25 an hour. Wow. So you might wonder, wow, Sarah, for this child labor, how much money did you make? I was 13, by the way, when I had this job. 2 hours, 3 hours, 7 hours. You can model this information by a linear equation in two variables. So here is an example of an equation that models that, right? So x is equal to child. Here, let's get my nice highlighted colors up available here. So x is the hours that I spend doing child labor, right? That's the variable. And y is going to be how much money that I made from that child labor. So if I multiply the hours that I work times the hourly wage, I'm going to know my earnings. So if I worked 0 hours, I made $0. If I worked 1 hour, I made $2.25, and so on and so forth. So here is a filled out table, and you might be having some really good questions here about the math, right? How many solutions does this equation have? What are they? And can you plot these solutions on a simple number line? Why or why not? These are really good questions. So the first one, how many solutions do we have here? Well, we really have kind of infinitely many solutions here. For every x value, there's one answer that comes out. So for 0, the answer that comes out is 0. If I work no hours, I make no money. If I work 1 hour, I make $2.25. 2 hours, I make $4.50. 3 hours, I make $6.75. In a way, each of these are solutions to this equation. But in real life, I wouldn't really work more than 40 or 50 hours. Technically, by laws at the time, I don't think I was even supposed to work 30. But, you know how they do. Technically, in the math world, I could just put in any number I want for x. And there are infinitely many numbers that I could plug in and just multiply by 225. I can multiply anything by 225. So technically here, there are infinitely many solutions. And can I plot them on a number line? Well, not really. This answer depends on my input. How much money I get depends on how many hours I work. So not really. I need actually some way to talk about x and y at the same time. And here's how we're going to do that. I don't just need one number line. I need two. Right? So I have my x, my hours of labor, and that's represented by this number line down here. And then I have my y, the money I made for that hard-earned labor, and that's represented by this number line here. Sorry, guys, I'm fighting a cold and a cough in all of the Unit 1 videos. So by the time you watch this, hopefully I feel better. Apologies for coughing in your ear. I have my trusty tea right here. So here is what the solutions look like when you plot them on a number line. This dot right here, this dot right here, this dot right here, this dot represents if I work 30 hours, I make $67.5. Right? You put the input value and the output value. This is called the Cartesian plane. It's two number lines that are connected here at the 0. This point right here is called the origin. You use it to graph equations in two variables, not just lines, but anything. And we're going to use it a lot this semester. There'll be a lot of graphing. And you have 4 quadrants. So you see how these lines, the x-axis and the y-axis, cut us up, right? The x-axis is the input variables for our function here. And then we have the y-axis, which is the output variables for our functions here. And those two lines cut our paper up into 4 pieces. They number the quadrants like this. First quadrant, second quadrant, third quadrant, and fourth quadrant. They label them in Roman numerals. I literally have no idea why. But it's just how math people do it, so that's how we do it too. But if you told me the fourth quadrant and you wrote fourth, I would know what you meant, okay? But I do want you to get in the habit of writing IV for 4 because that's how the math folks do it when they're talking about the Cartesian plane. And you are math folks now. So ordered pairs, x comma y, are sometimes called coordinate pairs. They tell you where you can find a point on the graph. X tells you the horizontal distance from the origin. So this is the x-axis. That's what the x number tells you. Y, it tells you the vertical distance from the origin. I've got some examples here for you. You always start at the origin, and here's how it works. So I'm going to graph some points here for you. So we're going to start with 0, 4. So if I start at the origin, the 0 there tells me don't go left, don't go right. Go 0 in the left and right, and go 4 in the positive direction. So I've labeled a 10 up here. So 0, 4. Here, let's get rid of these labels. 10's no good. We just want to go, let's label it by ones. 1, 2, 3, 4. Here we go, 0, 4. We could also have 4, 0. This next point, so that's our A. B, so now I'm going to go positive 4 and up and down, not at all. C, 0, 0, that's this point right here. D, we have negative 2, positive 1, so we start at the origin and we go out in the negative direction 2 and up by 1. E, we start at 0, 0, and we go up in a positive 3. Oh, we don't go up. Sarah, no. The first thing we do is go left and right. So positive 3, we go 1, 2, 3. And now 1, 2, negative 2. That's our E value. And F, we go positive 3, 1, 2, 3. And positive 5, 1, 2, 3, 4, 5. And G, we go negative 3, negative 5. You can see my little dot there hovering and counting. So I would think one way that you can help yourself get this together is challenge yourself right now and see if you can write the ordered pairs for the labeled dots here. So go ahead and pause the video and see if you can write down the coordinate pairs for at least 3 or 4 of them. Make sure you got it down. Ready? Some of you just waited and heard me take that sip. Didn't pause the video at all. That's okay, I forgive you. So for A, that's this one here. So you have to think, if I start at the origin, I would go to the right 1 and down 3. So that would be 1, negative 3. For B, I would start at the origin and I would go left 1 and down 3. So that would be negative 1, negative 3. For C, I start at the origin. I don't go left or right, so that's 0. But I do go up 1, 2, 3, 4. So that would be 0, 4. For D, I don't go left, I don't go right. I stay right there. It's 0, 0, aka the origin, the one who started it all. Origin. We're running out of colors, but that's okay. For E, we go to the right 1 and up 4. 1, 4. For F, we go to the left 3 and up 4. And for G, we start at the origin We go to the left 3. We don't go up. We don't go down. -3, 0. I hope that was helpful. And you might have noticed, sometimes I even start to swap my x and y's. That's a very common mistake. So if you make that mistake too, just double check yourself as you go. There's the slide I left myself to write it on, but I wrote it on the other slide. You can graph linear equations to show all those infinitely many solutions we were talking about by plotting points. And you can do that by following these steps here. So the first step is to fill in a table. You can choose values for x. Notice I put these random values for x here. You can pick any number you want to plug in for x. I usually choose numbers around 0 to start with. And then once you fill in the table, you want to think about the table as ordered pairs and then plot those ordered pairs on a graph. Then you'll be able to connect the dots and kind of see. So here's what it means to fill in the table. I'm going to show you how to do it by hand, and I'm also going to show you how to do it on a TI-84 graphing calculator. So if I say x is -2, we want to find the y value that goes with it. So what we'll do is we'll plug in -2 everywhere we see x. So we have y equals -4 times -2 plus 2. And that would be, oops, get back there, plus 2. So then we get +8 plus 2, 10. So whenever y is equal to -2, or whenever x is equal to -2, y is equal to 10. And now I'm going to do this again. -4 times -1 plus 2. 4 plus 2, 6. So whenever x is equal to, don't know what button I keep pushing. Whenever x is equal to -1, y is equal to 6. I can do the same thing for 0. So we have 4 times 0 plus 2. Anything times 0 is 0 plus 2. Okay. And so what I hope you're noticing here as a pattern, I'm going to add some color here, is that I'm just replacing x as a variable with a specific x value and doing some calculations until I get y. And these calculations are, to be honest, like not so fun, a little bit annoying. So if I plug in my equation here, -4x plus 2, and I push second table. Now you notice I've got a table here just like the one that we're working with in x's and y's, and I can plug in some numbers. -2, -1, 0, 1, and 2. So you can use that to save yourself some calculation time. Again, I'm showing you this to save you time and to help you check your work. Please spend 30 seconds of your time practicing these mental calculations. Because if you type something wrong into your calculator and your calculator's giving you goofy answers, you want to be able to have the intuition that something isn't right there. I think my pen might be running out of batteries. Oh dear. So now we've got our points here. -2, we've got all of our x's and y's filled out. We want to look at these not as data points on a table, but as an ordered pair. So I'm going to rewrite them, at least a few of them, so that we can see this is the same thing we've been talking about. We have all of these points that are solutions on our line. Our line has infinitely many points on it that work. Here are just 5 of them. And I can now plot these points. So I know I have the point -2, 10. I'm going to leave these in here. So let's see, here's 10. So this must be 2, 4, 6, 8, 10. Okay, so here's -2, 10. -1, 2, 4, 2, 4, 6, 0, 2, 1, -2, 2, 2, 4, 6, Now that looks like a line to me, right? All those points are lining up. If you're stressed out by the fact that I'm not counting a full box, notice the number of boxes between 0 and 10. I have 1, 2, 3, 4, 5 boxes, which means each box must be counting by 2s for this to make sense. So if that was tripping you up, hopefully that explanation helped. And then now, you can take out your trusty ruler and draw your line. So now we've graphed a line just by plotting points. And there's the points. If we use my graphing calculator, you can see that same line shaping up. Just for fun, I'll show you what it looks like if I try to draw a line. Oh boy. Yuck. Let's use that ruler. There we go. Look how much nicer that is. Use the tools available to you, right? Okay, my friends. So that's how you can plot a line by just plugging in points. You can use your calculator to help. And by the way, let me zoom out. There's our line. I almost don't even want to show you that. But you can use it to check your work. Why not? Distance formula. So there is a formula in geometry called the Pythagorean formula. And it says if you have a right triangle, meaning this triangle meets at a 90-degree angle down here, then you take the distance here and you take the distance here. And if you square those distances and add them together, guess what? You'll get this distance squared. And that is how we're going to actually get our distance formula. So let's suppose we have these 2 points here, 0, 4 to 3, 0. So I'm going to show you. We can kind of see if we look, right, the vertical distance here from 0 to 4. Well, we know that's 4. And the horizontal distance from 0 to 3, we know what those numbers are, right? We know that this is 3 in the horizontal distance and this is 4 in the vertical distance. So the Pythagorean theorem tells us whatever this c is here, that c squared is going to be 3 squared plus 4 squared. So c squared is going to be 9 plus 16. C squared is going to be 25. C is going to be 5. And don't feel bad if your calculations don't go that quickly. I've been doing this a long time, and I know a secret, which is that 3, 4, 5 is a famous kind of number sequence. It's called a Pythagorean triple. And it's called that because it's 3 consecutive numbers that solve a Pythagorean theorem that make a right triangle. So that's why I can do that so quickly. I've done it a million times. If it's your first time, welcome. So you could do it that way if you see a triangle. But what if you have a triangle that doesn't match up, right? You know, that doesn't match up exactly perfectly. Like this triangle doesn't have any zeros anywhere. So what we're going to do is we're going to use this formula, the distance formula that I've given you up here. And it says, look, if I take my x coordinates and I subtract them and square it, and I take my y coordinates and I subtract them and I square it, and then I take the square root of all of that, I'll get my distance. So let's go ahead and plug those in. I like to label x1 is 5, y1 is 10, x2 is -5, y2 is 2. I'm getting these 2 values over here. Let's get a nice color. Let's do a nice purple. We haven't done a purple. Yeah. So I'm getting these 2 from this point. And I'm getting these 2 from this point. I'm just breaking them down like that to help me make sure that I get this right when I plug it in. So my distance is going to be equal to x1 of 5 minus x2 of -5 squared plus y1 of 10 minus y2 of 2 squared So we're going to be equal to 10 squared plus 8 squared, 100 plus 64, square root of 164. Oops. And so whenever I have this square root of 164, I have to simplify that. Actually for now, I'm gonna leave it for you guys. I'm gonna let you do this. Take the second square root 164 and hit enter. It's about 12.8. So when you say equals, I want you to give me an approximate here. 12.8. Those squiggly lines means it's not exactly 12.8. It's really technically the square root of 164. You can see we have more decimal places, and those decimal places actually go on forever. So the squiggly lines mean, hey, we're cutting it off. I wanted to show you guys this visual example. So here's the points that we're working with, right? We just used that formula. This is the right triangle that we're actually talking about here. And so what we need to get is we need to get the horizontal change, 10. That came from subtracting our x points. So if we subtract 5 and negative 5, we're going to get that horizontal change. And then if we want the vertical change, and we subtract 10 and 2, we get that vertical change of 8. And so that's what this subtraction is going on about in here, is we are subtracting to get the distance of the legs of the triangle, and then using the Pythagorean theorem. I think that's interesting. Maybe you don't, but that's okay. I will still be your friend and help you pass this class. Let's also talk about the midpoint formula. So we know how to find the distance between 2 points. You also might need to find the middle of 2 points. I think it's helpful to ask you guys to think of it as taking the average, because most of us know how to take the average of 2 numbers. If you think for a second, I have 2 numbers. How do I take the average? Well, I add them up and divide them by 2. The midpoint of the line segment is the average point. So here is the formula that we use for that. I take my 2 x values for my point, I add them up, and I divide by 2. And I take my 2 y values for that point, for these points, and I add them up, and I divide by 2. So what this is going to do is this is going to give me the average x and the average y, which will be right middle of the formula. So let me go ahead and plug some stuff in here so we can see that work. So we have x of 7 and an x of 9. So we have 7 plus 9 divided by 2. We have an x of negative 2 and a y of 5. So we have negative 2 plus 5 divided by 2. Working that out, I get 16 over 2. So I get 8 for my average x and 3/2 for my average y. And then we'll check it with the calculator just because it's right here. I said 7 plus 2. That's not right. It's supposed to be 7 plus 9. And divide by 2. Great, that's 8. And then we have negative 2 plus 5. And divide by 2. And that's 1.5, which I know is 3/2. But if you needed to double check, you could say math frac 3/2. So this point is going to be right in the middle of those two. It's going to be the exact average. So here's a challenge for you guys. This is a fun problem. If you want to find the center of a circle with a diameter that has endpoints -4, 1, and 0, -6, what do you think? How could you do it? Spend a minute and actually just think how you would solve this, or what do you need to know to solve this? Maybe you need to know what the word diameter means. Diameter means the distance all the way across a circle. So if I have a circle, even with my help from my iPad, that wasn't a very circle-y circle. There we go. So say here we have a circle. The diameter is the distance all the way across. So they're saying, oh, my diameter has these 2 endpoints here. And I'm just going to label them. I'm going to label this one 0, -6, And this one, -4, 1. That doesn't really fit. Like, this isn't really an accurate graph on the Cartesian plane, but I'm just labeling them to help. So if we want to find the center of the circle, that's the point right in the middle of that diameter. Wait a minute. Middle point. We need to use the midpoint formula. And that's how I would work something out like that. Complete with drawing a picture and trying to figure stuff out. So I could use the midpoint formula, and I would say, okay, well, -4 plus 0 divided by 2. 1 plus -6 divided by 2. That's going to give me my midpoint. What am I doing? -4 and 0 are my x values. 1 and -6 are my y values. And dividing by 2 gives me the average. So then I'll be left with -2, comma, -5/2. And that's going to be the coordinates of my center point. So we found the center of a circle. Could you find the radius of a circle? I think you can. So to find the radius of the circle, whose diameter has those endpoints, remember, we've got this circle. And we've got a diameter, these endpoints. We want to find the radius. The radius is the distance from the center to the outer edge. So if we know this midpoint, -2, -5/2, and we know both of these points, and we want to know that red distance, we can use the distance formula. To find that here. Now, I'm going to leave that for you to try, and if you think you've got it, you can go ahead and you can post your answer to the homework forums. And if you do a nice job, maybe I'll give you some extra credit. Now you know everything you need to know to tackle this homework section. So do not wait to start until the deadline to start your homework. All right, my friends, if you wait until that day, you will be sad. The homework piles up really fast. So please get a start right away. I hope you're enjoying the class so far and having a good day. And I'll see you in the next.